Glenn.
Let me sit over here so I can work the device. So this is we spent all this time generating pictures of diagrams and things, and I don't know how many people are going to be able to see them. So I'm going to talk about Solaris containment, in particular feature of Solaris called Solaris containers, and also referred to as zones. So the emphasis of this presentation is about the security aspects of zones. So I will give a little introduction just to make sure everybody's on the same page, and then talk more about the security issues. Originally, the zones or containers project was started based on a BSD implementation called Jails, but the Solaris implementation is quite a lot more sophisticated and has many more features. The first idea is that multiple Solaris instances called zones share a single kernel. So this is a kind of virtualization which is kind of unique in that the zones appear to be individual Solaris instances, but when looked at from inside the zone, but from outside, the kernel can see there are actually multiple instances of Solaris sharing the same kernel that can be observed. So the zones implementation provides a fundamental security boundary, meaning that we isolate information and services and privilege and resources on zone boundaries, and every process that runs in Solaris has a zone ID corresponding to the zone that it's running in, and processes cannot move between these zones because it is a fundamental boundary. So zones are constructed by a global zone administrator. The global zone is the name that we give to what historically was simply Unix, and now we call the environment, we call it the global zone to distinguish it from the other zones. And an administrator with sufficient privilege running in the global zone can create multiple zones, and the zones themselves are controlled administratively through a series of steps. The first step is through configuration, in which the administrator specifies the networking and privilege sets that are associated with the zones. And I'll talk a little bit more about privilege sets on the next slide. But this is the same feature that Scott was just talking about, where we implement the principle of least privilege, but we can do it on a zone boundary, and then that sets an upper bound for the processes that run in that zone. The next step is installation. This is actually the construction installation of the packages for the zones and the initialization so that they can run. The next step is to mount the file systems for the zone, which we call making it ready, and finally running the zone or booting it, in which the system services and user processes are started. So this is actually all controlled individually, step by step, by the global zone administrator. The next picture, which I don't know if you can see, explains how zones architecturally are distinguished from the global zone, and they all share the same kernel, and that one use of zones is to isolate individual types of applications like a web server or a database server on a per zone basis. And the advantage of this is that you have separation of data, you have separation of failures, isolation, attack vectors, and so on, because everything is separated by these fundamental zone boundaries. So I'll talk and this slide is entitled Process Security Features of Zones, and I'm going to talk about how, extending what Scott talked about, how we can use the privilege mechanism and other mechanisms to isolate and protect processes that are running in zones. So one of the interesting things about zones is that a process can't escape from the zone that it's in, nor can it create any child processes that can escape from that zone. And a process can't observe anything that's going on in any other zone, including the global zone. And a process can't send signals or in any way cause failures in other zones, in processes, other zones. Another interesting security feature is that we can audit all the activities that are going on in any of these zones in a tamper-proof manner, because the global zone and the global zone audit daemon are running without the possibility of being interfered with or attacked by the processes that are running in the non-global zones. They can't detect that they're even being audited, for example. On the other hand, kind of flipping this upside down, with sufficient privilege, an administrative process in the global zone can observe everything that's taking place in any of the other zones, including observing what the processes are doing, detracing the individual processes that are running in the non-global zones, and so on. As I alluded to before, each zone has an upper limit, what we call the privilege limit, that is the maximum privilege set that is available to any process, even super user, running in that zone. So no process in a non-global zone ever has as much privilege as the global zone. They're always running with reduced privilege, and you can further reduce those privileges if you have a specific purpose for your zone where you don't need any super powerful processes. In that case, it prevents a process from asserting more privilege than the zone has. So even root is limited by the zone's privilege limit. And furthermore, you can isolate through service encapsulation. There's the SMF, or service management facility, is instantiated in each zone, and so you can specify the zone's individual services and control which services are enabled independently in each zone. Because of all this, you have a reduced attack vector because you have smaller set of processes, smaller set of applications, and smaller set of privileged applications that are running there. And because of the way zones are built with ZFS cloning, they can be very quickly instantiated. You can effectively, once you've built your first zone, you can create snapshots and clone a zone on about 1 per second. You can create hundreds of zones in just a couple of minutes. So next I'm going to talk about the resource security features of zones. One of the important characteristics is because the zone file systems are mounted from the global zone rather than within the zone itself, the zone processes can't remount or cause those file systems to be mounted read-write unless the administrator in the global zone has specified that. So we can easily create /user, for example, or /opt, or any of these other file systems that have executables in them to be read-only and immutable, so that even if you're root in that global zone, in the non-global zone, you can't affect or modify process executables. Similarly, we have a variety of different options in the way the network can be configured, but they're all under the control of the global zone administrator. So by default, we can share what they call the IP stack, so that the administrator in the global zone controls the IP behavior in all the other zones, or we can delegate to individual zones what we call an exclusive stack, in which some of the rights, for example, picking IP addresses and configuring routes and so on, can be done by administrators in the non-global zones as well. We also have, as far as namespace separation, because all the resources that are controlled by the kernel are effectively polyinstantiated, meaning that there's an instance or a different name for them in each zone, we never have any collisions. Any resource, even things like /temp, are always unique in each zone. System 5 IPC, any of the services, any of the resources that are maintained by the kernel appear to be unique in each zone through virtualization. Similarly, there are no devices, hardware devices, that are directly available in the zones. It's all done through virtualization. Even in the case using our new crossbow virtualization technique for network virtualization, it would appear to processes running in the non-global zones that they have physical network interface hardware, but it's all done through virtualization. So they have a MAC address and they have all the characteristics of hardware, but it's actually under control of software. And you could actually make it look like there's multiple hardware NICs on a device when there's only one. If you can see it, the next picture talks about another application of non-global zones, which is as used in trusted extensions. So trusted extensions is a special configuration of Solaris in which the zones are used to represent different sensitivities of data, where information is protected based on how valuable it is. And this is often used in military and intelligence agencies where they have top secret and confidential information that needs to be protected. We can isolate that information by its classification into corresponding zones and corresponding networks. So because of the features of zones that I just talked about, we can ensure that information cannot flow between label boundaries. So not only in the case of the process communication, but network communication, file system communication, System 5, all the operating system services are all protected to not violate these boundaries. And that's why Trusted Extensions is able to be accredited as a multi-level system, because it can assure and ensure that there's no a violation of those label policies. Because of other extensions that have been made, we can actually share physical hardware such that we have a single network interface or corresponding unique network interfaces for each zone, and we can have the appearance of separate communication paths for each zone. So Trusted Extensions has very strict policy sharing rules. By default, nothing is shared between zones, but we can allow administratively from the global zone certain files can be made read-only, available what we call reading down from a high sensitivity label to lower. We can have some sharing, but there's no violation of what we call the Bell and Apogee or multi-level security policy. Trusted Extension has been evaluated by common criteria to conform to label security protection profile. It implements both a multi-level secure policy and another policy sometimes called MILS, or multiple independent levels of security, in which we can assure that information doesn't flow at all across those boundaries. And in the case of Trusted Extensions, we've extended the GNOME desktop so that the GNOME workspaces correspond to these labeled zones. And when you change your GNOME workspace, you actually change to another zone. There's effectively a one-to-one correspondence between GNOME workspaces, security labels, networks, and zones. So that all works the same. And this allows us to have complete process and data compartmentalization. So that's kind of the end of our formal talks. We have, if you can see the last slide, there are a bunch of URLs mostly dealing with OpenSolaris and blogs, which I'm not going to read. But OpenSolaris, if you go to OpenSolaris.org, you can search for any of these things, or frankly, just Google any of these topics and type OpenSolaris, and you'll hit these pages.